But another way that you can get that common terminology is by using a common system specification. I think I already mentioned that. But ontology matching inevitably will become necessary. So that's how you can combine it together, combine the terminologies. But there's another issue that comes in, and that is people have a tendency to modify the syntaxes for each of these models for their own specific situation. When you're dealing with the primary components of the models, like the and or gates, which are the foundation because they're absolute basic Boolean logic with fault trees, you're not going to see much variation. You're not going to see much deviation. But once you get into the more difficult, more complicated situations, I mean, engineers have some degree of creativity. So they may manipulate the syntax in a slightly different way, in a way that makes sense to them because things aren't as clearly defined. Or they may come up with completely new syntax. And in a lot of ways, that's just, again, natural language. People have a tendency to come up with their own things on their own terms and use whatever happens to work. They find something that works, whether it be a model or a word, that they can share and all corporately understand, and they apply it. Now, that's great when you're dealing with one particular company at one particular location. But when you're dealing with this, trying to make a standard formula for everybody, you've got so much variation it's insane once you start getting to the more complicated stuff. So that's going to be an issue. We have a standard, but we don't necessarily adhere to it. In a lot of ways, it's just like the browsers. You know, if you compare how Mozilla, Chrome, Safari, and Internet Explorer all adhere to the World Wide Web Consortium standards, it's atrocious. It's so picky and choosy. And that happens too with fault trees and state charts. They just use it however they decide to. And finally, a little bit of an ambiguity in fault trees that also needs to be resolved. As I've already said, we need formality. We need rigidity. We need to know with a computer science and mathematical precision in these models, when things happen, this is how they happen. There's no ambiguity. There's no guessing. It's boom, 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 boom. Perfect mathematical logic. That's what we want to see. But the problem that you have with fault trees, and this is actually quite connected to what I just talked about with the makeshift syntax. Fault trees, while they do a really good job of showing a combination of events, they don't have a standard specification for how to deal with timing or order of events. Boolean logic doesn't say this has to be before this. Boolean logic just says this and this or this. And it can happen in any order we want. You just have to have all of the variables in to make a determination of the Boolean. But not all safety problems are just a matter of combining certain situations. A common example, I think, actually from the IFSS paper itself, is say you've got a gas burner, and this is an order of events issue. Say I flick the sparker, which is just a button press kind of thing. It happens and it's done. And then I turn on the gas. Well, you know, you might get carbon monoxide poisoning because natural gas is just running off the hook, but you're not going to have an explosion, and that's the top level problem that we're dealing with right now. So, order of events. You can't just say switch or spark and gas valve on, because if you turn them on at the same time, there probably won't be any gas out there. So you have to turn the gas valve on first and then flick the sparker to get a burn started or to get an explosion, either one. And that's where the other part comes in. This is something that Kelly Tran realized last year. Temporal logic is important. And again, fault trees don't do this very well. You have to have, IFSS talks about it a little bit, but there's no real standard with fault trees for doing this. You got to have that gas on for an extended period of time. Say, like, if you start your gas and you have to have it on for maybe 3 seconds to even get a burn when you spark, when you press the button for the sparker. So first of all, even to get it to work, you've got to have a certain amount of time in there. But for it to screw up, maybe the gas has to be on for 30 seconds. And if it's on for 30 seconds before the spark happens, maybe an explosion occurs. A catastrophic explosion that destroys the oven or the stove and probably the person operating it. So timing is important. You have harsh chemicals and leaks. Those are real safety concerns. And I could totally see them being an issue with the nuclear systems. So you've got timing and you've got order of events. Again, kudos to Kelly Tran for figuring that out. Ethan was our resident UML expert, and I think he was also the one that found and primarily designed our analyte brick system. So kudos to them, just shout outs to them, whereas I was doing the examples. But I think that gives you a good overview of the problems. Again, time is important. Thank you, Kelly, for figuring that out. But just to review what all we've talked about here, we talked about why state charts and fault trees. We've talked about the fact that syntax conversion, at least for the standard fault trees and state charts, has already pretty much been figured out. We found that finding examples is good, because that way we understand how these things are actually being used, and we can do our best to adapt our model to something that will ultimately be useful. We found that we're dealing with fault trees and state charts because we need rigidity. We've talked about needing to find a situation that justifies the need for the IFSS model in the first place. Something like an obscure system state that causes a catastrophic failure that none of us ever thought about before. We've talked about the need to explore ontology matching between state charts and fault trees, and the natural language nature of the syntax usage, where it just varies among different groups and organizations. And finally, we've talked about temporal logic and the need to consider timing and order of events when you're dealing with safety issues. And I feel like that really gives you guys an idea of what we accomplished last year and what we think needs to be done. So good luck. Hope you can get a lot done, and I look forward to seeing what you have to do. Over and out. Enjoy your summer.